Okay, this is integrated 2, 2.3.2, determining similar triangles. This is basically a continuation of 2.3.1, where at the end of that, we were doing some proofs of triangles. So same idea here, except for trying to prove that they're similar, not necessarily congruent. So the first thing that I would recommend that you do is look to see if you have met the requirements for one of the three. So remember, the three is angle, angle, similarity, side, 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 similarity, or side, angle, side, similarity. Those are your three choices. So taking a look at this picture, it looks like I have angles that match, so that's good. So I've got an angle. And then I want to take a look at the sides that surround it. So it would be side, angle, side. And it looks like I've got sides that should be matching up. So the only thing I'm really going to do off to the side is just even see if the ratios match up. There's no point doing a full-blown proof if they're not going to be similar to each other. So again, you have to decide if you're going to go from the larger triangle to the smaller triangle or the smaller triangle to the larger triangle. I'm going to go larger to smaller just because it's left to right in the picture. So if I take a look in the triangle on the left-hand side, it looks like the smallest side here is going to be 12. And I want to compare that to the smallest side on the other one, which would be 9. So off to the side, really just like scratch work, I would try to figure out what 12 over 9 is. Once I divide that and simplify, I get 4/3. Okay, so if these are actually going to be similar to each other, then the other ratio that I'm looking for is going to have to be 4/3 as well. So there's the angle. All right, so the other side that I want to use is the leg. So 16, and that would be the medium side, as would 12. So let's do a quick little check over here on 16 over 12. Divide those, looks like we get 4/3. Okay, the ratios are the same. All right, so that was just my side work. That's not necessarily my proof. So at this point, you want to start kind of laying out what we've been doing recently. So the first thing that I would do, if it were me, and I'm going to go ahead and pause and kind of fill this in and pause and fill it in, is line up all of your measurements. So put all of your measurements that are supposed to go together. Remember, we're not looking for congruence here. We're actually looking for this 4/3 business. So I would put the 16 and the 12 in bubbles or boxes right next to each other. And likewise, I would put the 12 and 9 in bubbles and boxes next to each other. Just make sure that you keep them labeled. So I'll do my measurements first. Okay, so I went through and I filled in all of the stuff that I kind of extracted off to the side. I just want to formalize it a little bit more. All of the stuff was given to me because it was in the picture. Now I color coded it so I know that those were the pairings that I was going to put together. And then I chose to go large over small, so I am going to stick with that. So now I'm going to take these measurements themselves. I'll show you what I'm going to do. So I'm going to do GH over KL, just like I did in the last video. I'll make sure I don't run out of space here. And then I'm going to rewrite it as 12 over 9, and I'm going to go ahead and simplify it. And I'm going to show that the ratio that I get is 4/3. Taking that information, getting the 4/3, and then from here you can call it division, like I said in the previous video, or you can call it computation. We need to do the same thing with the next orange one as well. So I now have those ratios set up, and I still need to deal with the angles off to the side. But you guys know we've been talking about if the measures are the same, then we can say that those two are going to be congruent to each other because of definition of congruence. So I went ahead and pulled my angles together with definition of congruence, but now I also went ahead and pulled together the GHKL 4/3 with the IHJL 4/3, and they're just identifying them as equal ratios. So basically what I have here now is I've been able to show that I have the same ratio comparison between the orange sides as I do between the red sides, and then I have the angle between them and is going to be congruent. I think we have enough information now to say that the two triangles are similar. And that finishes the first problem. The only thing I would recommend that you really pay close attention to, because we've been doing proofs of congruent triangles, is just making sure that you're using the correct symbol. So if you take a look inside the last box, I am using this similarity, and I am identifying it as a similarity. Okay, so here we are with 2-90B. I would do the exact same thing. So take a moment, match up the sides together that go together based off of size, so small with small, medium with medium, large with large, and see if the ratios are the same before you dive headfirst into a full-blown proof. So I compared the 4 and the 8 and thought, okay, this is 2 over 1 or 1 over 2, depending on the direction that you chose to go. And then I went to the medium side, the 5 and the 9, and we're done. There's absolutely no way that 9 over 5 or 5 over 9 is going to turn into 2 over 1 or a half. So since those are not the same, triangles are not similar. So again, don't get yourself full blown into a proof if it's not going to work. And then this is our last one. So why don't you see if you can do this one before I do it for you. My recommendation, though, is make sure that you pay attention to all of your possibilities. Again, it could be angle-angle similarity, it could be side-angle-side similarity, or side-side-side similarity. So on first glance, you may not necessarily see that the angle M is reflexive. So I decided to redraw the pictures for you. So I took the small triangle inside. You notice the corners that I marked green and purple at the M and the S, and I traced that in red and then brought that tracing out to the side so that you could see it. Then I went through and I traced the very large triangle, the MVT triangle as well. Notice that I still had the green and the purple markings. So in this case, you can see that that angle M, that exact angle M, belongs in both of the triangles, which means it's technically reflexive. So based off of this, I do have enough information to prove that the two triangles are similar to each other because I have two angles that are congruent. So that means that the third one has to be congruent, which means I've got similar triangles.